Hey Chemistry, Mrs. KJ here, going over part two of 3.05 metals. And you should have written down this information about the alkaline earth metals. So they are soft, they react with water almost as much as the alkaline metals do, and they have two valence electrons. So based on that, where are they on the periodic table? They are, of course, in group 2. Remember, we can also call a column going up and down. So the second column, but more often we call it the group number. So group 2 contains the alkaline earth metals. So here you can see beryllium. Beryllium's cool because it absorbs a lot of heat. It is used for constructing of spacecrafts and aircrafts. And notice some of the properties when you're looking at it. Again, because it is a metal, it is quite shiny. If we look at magnesium, going down is another metal. Magnesium is very light, and so they actually use it for airplanes again. And they can also use it for bikes and other things that need to be lightweight but strong. Now, calcium you have heard of before. Calcium you need for what part of your body? The bones. And if you've ever taken a calcium tablet, what color are they usually? Usually they're white, like your bones. So you don't really think of it being a metal, but it is. Like I said, most elements are in fact metals. Strontium is pretty cool. It's used for flares and fireworks. Actually, a lot of metals are used for fireworks, and each of them give off different colors. It's pretty cool. We'll be talking about that a little bit later, about how based on where the elements are located in the orbitals, that talks about how much energy they have, and that talks about what color of light they actually give off. And actually, since I'm mentioning it now, I'll just tell you. So like potassium gives off like a lilac, light purple color. Sodium's orange. Um, you can get strontium, which is a very deep, bold orange. Let's see, copper gives a green color. So if you are looking at fireworks and they are green, they quite possibly have copper in them. We have some that are very magenta in color, such as lithium. Magnesium burns a very, very bright white. And if you're thinking, okay, it's white, no big deal. No, I'm talking about the kind of bright light, like if somebody flashes a camera right in front of your eyes. It's so bright that in the lab, when you do burn it, you actually are not supposed to look directly at the flame because it can cause damage in your eyes. So it's a crazy bright white. So again, we'll talk more about that later, but it was just kind of cool. Another thing about the elements is that you can tell what element it is based on what color it turns when it's part of a compound that is then put on fire. Pretty awesome. So next going down, we have barium. And barium, again, silvery in color like a lot are, used in spark plugs, fluorescent lamps. And we have radium. You can see it's kind of glowing because it is radioactive and it has been used to destroy cancer cells in the past. In their pure forms, the alkaline earth metals are very shiny. Here you can see that bright, bright white that it gives off. They're good conductors of heat and electricity. You can see that it's pretty easy to break them. And again, like the other ones, they're going to tarnish in air, which is why you want to keep it in oil. There, of course, they're putting it in water. Now, because the alkali metals and alkaline earth metals are so reactive, you're not going to be digging in your backyard and suddenly scoop up a shovel full of sodium or magnesium. Why not? Well, because if it touched the water in the air, what would it do? Start on fire, right? So you're never going to just find these by themselves. They're always going to be combined with something else, usually one of the nonmetals, okay? And so they might combine, for example, magnesium wants to give up 2 electrons. Which group wants to gain 2 electrons? That would be the oxygen group. Now, they might also bond to the other groups, and we'll talk about all that coming up later too. But in nature, you're going to find them bound together with something. You're not just, like I said, going to go digging in your backyard and get a shovel full of potassium. So the last thing for this section is I wanted you to write down some properties of metals in general. So please start a new page in your notebook. And on this table, we're going to write down a property. You're going to write a column for metals and a column for nonmetals. I know we haven't talked about nonmetals yet, but I'd like you to write it down because we'll be getting to that. So appearance. Metals are shiny. Nonmetals are dull. State at room temperature. So your metals are going to be solid, all except for mercury, which is liquid. The nonmetals, about half are solids, about half are gases, and then one, bromine, is liquid. Density. Very high for metals. They feel heavy for their size. Nonmetals are low. They feel very light. So if you had a chunk of a metal and the exact same size chunk of a nonmetal, what can you tell about how it would feel? The metal would be a lot heavier. Strength, metals are very strong, nonmetals are weak. Metals are malleable or brittle. Well, they are malleable. Malleable means they can bend without breaking. So think about a wire. You can bend and twist a wire and it doesn't break. However, nonmetals are brittle. They break or shatter when they're hammered. So again, think about like if you ever went to the Renaissance fair. You know that they can hammer the metals into different shapes, especially when they heat it, and it bends really nicely without breaking. So that's more about malleable. Conduction of heat and electricity. Yes, metals easily conduct heat and electricity. Nonmetals do not. They're poor. So we call them good insulators. Except for graphite for electricity, you don't need to remember that. It's a specific form of carbon, like what is used inside pencils. So we call it pencil lead, but really it's pencil graphite. Magnetic. Some are magnetic, like iron, cobalt, and nickel. None of the nonmetals are magnetic. Sound when hit. They make a ringing sound like a bell, and nonmetals make a dull sound. And ductile. That means you can pull it into a wire. Yes, of course you can pull metals into a wire. No, you do not pull nonmetals into a wire. So make sure you have these all written down and then go ahead and do the worksheet.